All right, it's 1 p.m. We're going to go ahead and get started. Welcome to Advanced Kentucky's bonus week of AP Calculus AB online review sessions. My name is Aaron Timmons. I'm the Advanced Kentucky Mathematics Content Director. I'm joined by our current Access to Algebra Content Manager, current AP exam table leader, Michael Marshall, and today's presenter, Mr. Tony Record. So we're super excited you all could be here. We're about 1 week away, actually, from the AP exam exactly. So teachers, students, we are here to answer your questions. So let's go over a couple introductory slides here and we'll get started. On the slide you're looking at, please make sure you've gone to that bit.ly link to get the handout that we will be using today. This review session is intended for a Kentucky audience. However, we know we've got people from across the world joining us. So teachers, students, welcome. We will do all we can to make this an equitable session for you. Any participant causing a disruption to the session, however, will be removed. So please act appropriately. Contact information for Advanced Kentucky, myself and Michael can be found here. Please feel free to reach out to us with any follow-up questions. Give us a follow on Twitter, Facebook, anything like that. We will be happy to answer questions. Microphones will be disabled for the entire meeting. Your videos, we ask that you leave off. If you turn them on, you'll be removed. Please use the chat feature at the bottom right-hand corner of your screen. You can chat directly with Michael or myself. Any questions that you have, we will get those to Tony. He has told us he is perfectly fine with us interrupting him, so we'll be ready to break in with your questions, so please ask away. KYAP2020.com is the place to go to find all resources for AP Math, Science, or English. Today's recording will be posted to the website by the end of the day. You can find our other 4 content review sessions posted along with handouts for Calculus, AB, and BC. Also, for those of you that are in the other AP Math, Science, or English class, those can be found there as well. So please make sure you're looking there. And that does it for mine. So I'm going to turn things over to Tony. He can give us a little bit of background about himself. I'm sure most of you already know him, recognize him from the AP Live videos, but he can give us a reminder as to who he is and what he does. So Tony, it's all you.
All right. Well, thank you very much, Aaron. Welcome, teachers and students. And this is a pretty class operation. I love that intro music. I think it rivals our AP Live intro music a little bit. That's pretty cool stuff. As Aaron said, my name is Tony Record, and I'm kind of your neighbor to the north for most of you. For those of you that at least live in Kentucky, I'm an Indiana boy. And I didn't know if you realize this. Teachers, you probably realize this, but if it wasn't for this virus thing, do you realize that about an hour ago, you would have just exited your AP testing room for calculus and you would have had the test taken? It's hard to believe that the original scheduled day was today, May 5th. But we can look at it a different way, and that we have another week to prepare and do some things and prepare for a test that's going to be a little different, definitely a little shorter, and that's some of the things that we're certainly going to talk about today. So we're going to turn this thing into a good thing. And I've told students and teachers that all over the world that, you know, this chapter of your life isn't over. It didn't get ended for any reason. You just have a chance to rewrite it. And the best way to rewrite this chapter is to rock not only your AP Calculus exam, but any exam that you're going to take for advanced placement over the next 2 weeks. So that's what we're going to do. As Aaron said, I am a teacher from Indiana. I teach at Avon High School, which is just a suburb west of Indianapolis, and I teach at a pretty large school that has a lot of students that take calculus. It didn't always start that way. I remember when I began, we had 12 students, and we now have over 300 students that are taking calculus. And it's always wonderful to be able to share the experiences that I have and try to instill some of the things that worked to build a big program at Avon to teachers and students all over. So that is a little bit about me. We'll talk a little bit more about some of the things that I am doing with my own students, because in the midst of all of this e-learning with you all and with the College Board on YouTube Live each morning, I also have some students that I have to worry about here back at home. And so we'll talk about some of the things that I'm going to do with them in the last few minutes leading up to the test. So we are not going to mess around, guys. We are going to jump right in. And hopefully there's a document that you all could have had access to start looking at these problems as we solve them together. And I want to tell you that one of the biggest challenges that both myself and my partner Brian Passwater face on our YouTube Live sessions is trying to develop problems that are different. We didn't want to use problems that students had perhaps seen time and time again, because I'm going to let you guys in on something. Your teachers are pretty good. I've worked with a lot of them, and they're so good at finding resources for you to use. So we wrote original questions that we use each morning. Now, although our sessions are focused on BC, so much of that content had AB material in it, and we were able to strip away some of those questions. And that's for the most part what I've got prepared for you. So depending if your teachers pulled some of those, they may have used some of these, maybe a problem or two might look familiar, but I'm hoping by and large, most of you are seeing things that you may have never seen before. Let's go ahead and read through the first question, maybe answer it, and then we'll talk about what is it about this year's exam that has this potential to be a little different than in the past. So here's our problem number one. It says we have a graph of f prime, the derivative of the continuous function f, it's given above, on the closed interval -5 to 4. The graph of f prime consists of 4 linear pieces and a quarter circle centered at 2, 2. For x greater than or equal to 4, we know that f prime of x is -2 e to the 4 minus x, and it is known that f of 0 is 6. The function g is defined as g of x equal 3 minus the definite integral from -1 to x of 2 f of t of 2t plus 1 with respect to t. Wow, there is a lot of stuff going on in that problem. You've got a graph, you've got a function defined as an integral, and a lot of text. But one thing that you don't have, aside from that f prime equation, is a lot of analytic stuff. In other words, you don't see a lot of equations, things that you could probably just type into a calculator very, very easily. And I think that's the kind of questions that we want to think about seeing next Tuesday on this year's AP exam. So let's take a look at this part A, find f of 4. Well, I look at this f thing that I'm trying to find, an f value, and I see, okay, of all the things that I'm provided, I see this f prime graph, and I think that's the thing closest related to an f. I just don't see this g of x helping me. It's very likely g of x is going to help me sometimes later in this problem, but it's just not going to probably work for part A here. So if I think about what would I need to do to this graph of f prime to turn it into an f? And obviously the answer would be to take its antiderivative. But it's kind of difficult to take an antiderivative of a graph. You have to be thinking a little bit more holistically about how that can be done. And because we were given a lot of information about these wonderful, friendly geometric pieces, lines and quarter circles, we have a chance to do just that. Now, if we decide that we do want to integrate the graph of f prime, we have to think about it from a standpoint of boundaries. We have to start somewhere, we have to end somewhere. And given the fact that f of 4 is something that we're trying to find, then it's very, very likely that we probably want to include 4 as one of our boundaries. But that's half the battle. We have to figure out what the other boundary is going to be. So if you kind of think about this a little bit, read more through the question. If you end up reading the stem once or twice more from after the first time, that's perfectly acceptable. You find that you got some information here. F of 0 is 6. So what better two values to use than 0 and 4 to get this process started? Because we know that if we integrate f prime, we're going to get f. And we know that we can use the fundamental theorem of calculus, where we can plug in a 4, we can plug in a 0, and we will subtract those. And now, hopefully, we can start extracting this information from the stem of the problem. So what do we have? Well, we have this integration of f prime from 0 to 4. What does that really mean? Well, that means we're going to find the area between the curve and the x-axis along the interval from 0 to 4. And that's a little tricky. We're going to have to think about that a little bit. You can see that our first area, if I kind of shade this in this light blue color, we're going to have something that looks like that perhaps. Okay, well, that's fine, but that is not a really friendly geometric shape that at least I remember. So we think a little bit more strategically about what about finding the area of this entire square, that 2 by 2 square, which of course we know to be 4. And then we could subtract out the area of this quarter circle, what I'm shading in orange right now. And once that's removed, we have that light blue shaded region that's there. All right, so that quarter circle has a area formula of 1/4 pi r squared. It's probably a good formula that every student should know by the time you get to to AP Calculus, right? However, we can't stop you, and nor do we even, and when I say we, the College Board, they can't stop you from having your formula sheets out in front of you. In fact, it's probably expected. We're going to talk more about that later. You don't want to have piles and piles of papers and books in front of you, because then you can get lost in them and you can start spending so much time looking things up that your clock is going to tick away. So a few formulas handy, nothing wrong with that. It's not against the rules. So we're going to find f of 4, and we know that our f of 0 was equal to 6. So at this point, I suppose we could just add the 6 over to the other side, and you can write this in whatever order. Let's say I write it like this. Let's say I'm kind of being lazy today, and I don't really simplify much of anything. Could I leave the answer like that? And the answer to that is yes, I could. I can leave the answer like that. That's perfectly acceptable. Now, I'm not quite finished with this integration from 0 to 4. I noticed I got a little bit ahead of myself. So I am going to go back to this step. I apologize for that. See, I start talking and I lose my train of thought. Anybody ever do that? What I need to do is I got to finish finding this area. I only stopped here at this light blue part. So I'm going to go ahead and start thinking about this shape here. Now that shape is a triangle. It looks like a 2 by 2 triangle, if I'm not mistaken. And the most important thing to think about is where that triangle is located. Below the x-axis means we're going to have to think of that area as being a negative. So we're going to subtract out a formula that would depict the area of that triangle, which is 1/2 base of 2, height of 2. And now I can say that entire area is equal to f of 4 minus f of 0. So now let's see what I got. If I go ahead and I'm going to take that plus 6 out just for a moment, and I'm going to tack on this extra minus 1/2 2 times 2. So what I have here, just to recap, is everything that was on the left side of this equation. And now I'll add the f of 0 over, which remember was equal to 6. Okay, now getting back to what I was saying before, I could be lazy and I could leave my answer just like that, and that's perfectly fine. That's always been a rule. That's never been an issue on any year that the advanced placement exam in calculus has been given. This year, because of the fact that you have less time, right? You have 2 questions that you're going to end up having a combined amount of time of 40 minutes to be able to answer. It's very, very likely that you probably want to leave all of your answers unsimplified. And if you feel kind of queasy about that, my advice would be to maybe run through the test the first time, and then if there's time on the clock before the submission process needs to begin, you could go back and make some of those simplifications if you want. Sometimes students like to do that just to see if their answer makes sense. For instance, in this problem here, I get 8 minus pi. 8 minus pi is about 5. Okay, maybe 5 could be a reasonable value for the graph, for the f value when x is equal to 4. We don't have any way of really knowing because we won't see the graph of f, but sometimes it's kind of nice to get that reassurance. Okay, let's move on to part B here. Part B is going to ask us to write an expression for g prime and g double prime. Now you can see how the focus has completely changed. The focus is now going to be upon this function g of x in its entirety now. So you're going to want to pretty much take the graph out of the picture temporarily and focus on that. Notice that this is written not so much as your typical everyday kind of function that you might be able to type into a calculator and take its derivative so easily. So you're going to have to think about this a little bit perhaps and think, okay, well, what is g prime of x? Well, if I take the derivative of this expression, I know the derivative of 3 is going to be 0. And then I see a minus sign, which I'm just going to plop that down right now so I don't forget about it. And now we are forced to take the derivative of this integral expression. Right? Sometimes teachers refer to this as the fundamental theorem of calculus part 2. In some classes, it's called part 1. It really doesn't matter because it really depends on the author of the textbook and what their philosophy is. But it's one of our fundamental theorems of calculus that says if you take the derivative of this integral that has this constant lower boundary, your upper bound x can plop right in the place of that variable t. Now you have to pay attention to the fact if that variable up on top has a derivative that's significant, a derivative that's not equal to 1, you're going to have to multiply by that derivative as part of your chain rule process. Notice that that's not going to be an issue, as that upper boundary in this case is x. So what I have is negative quantity 2 times f of 2x, and then I still have the plus 1. See, that's kind of tricky. In this particular problem, it's so easy to want to get rid of that 1, thinking that that is something that I need to take the derivative of. But that particular expression is housed in that integral, and it's only the t value that gets swapped out and replaced with the x. So we got to be very, very careful about that. All right, now we go to g double prime. For g double prime, we're going to take this derivative. Now, this one's a little bit more traditional. We can pop that negative out in front if we'd like, and then we can start this derivative process. 2 times, okay, what is the derivative of a function f? Well, typically speaking, that's f prime. So we'll just call it that, f prime. Don't change the 2x, but also keep in mind that you have just taken the derivative of a composite function where we have something a little bit more significant here than just an x. So you're going to be thinking chain rule here, right? You're going to be thinking of this as being your value of u if you used a u substitution to do your chain rules. That derivative of u is certainly going to be 2, and thus we have to tack it on at the end. Now the derivative of the 1 is going to 0. That's perfectly acceptable. And now you have an answer that, if you choose to, you could simplify a little bit. In fact, I think this answer might be used in a future part of this FRQ. Okay, let's see what part C has in store for us. In part C, we're asked whether or not this graph of G, this graph that we can't see, has a local minimum, local maximum, or neither at x equal 2. So we have to start those wheels turning in our head. Right? A lot of times I tell my students, don't let calculus stand in the way of the calculus that you already know. And I know that seems like a really strange thing to say. Well, what does that even mean? It's likely that you're sitting there and you're like, oh, yeah, I know how to find local or relative mins and maxes. Isn't that where you take the derivative, set it equal to 0? Exactly, right? You know what's going on. Don't let the environment of a problem bother you. Don't let the way that it's worded and the way that it's structured psych you out of the calculus that you're probably pretty good at. So if you feel like, okay, local mins and maxes has a lot to do with taking the derivative, by all means, take that derivative. So take g prime of x, and if you recall, we just did that a moment ago. In fact, from part B, we have negative quantity 2 f prime of 2x plus 1. Okay, now what does it mean to have a local min max or neither at x equal 2? Well, we're kind of giving you the fact that x equal 2 is that potential critical point. But I use the word potential because this is sort of a yes or no question, because it starts with the word does. So to determine whether or not we have this max or min at 2, we're going to have to use 2 inside of this function. We're going to have to replace our x with 2 and check out or analyze what the result is. Sometimes that's why calculus is a hard class for you guys. Maybe throughout the year you've struggled with this course, but you've been pretty good at all your other math classes. And it's easy to kind of blame external factors. And it's easy to blame the teacher. I've had my students do that many times. But the fact is, calculus is so connected to you having to analyze mathematics, and you're just not quite used to doing that. But the more you're in calculus, the better you get at it, trust me. So in this particular case, we're going to go ahead and figure out what's this value of f prime of 4. And in doing so, we can go right to here's our x value of 4. Remember, this is a graph of f prime. So the value that we get would be negative 2. So we're going to replace that f prime of 4 with negative 2. And then after we look at this a little bit more, we see, well, that's just negative 4 plus 1, but we still have this negative sign in front. So we have what? Negative 3, I suppose. And that's equivalent to positive 3, right? And we sit back and think, what does that mean? Well, a common mistake is to think, oh, that's a positive number. Is positive a maximum? Or maybe you're thinking second derivative test. Oh gosh, then you're thinking minimum. Well, the fact is, it's neither, because the derivative, the first derivative that we're focused on, doesn't equal 0, nor is it undefined, and that's the criteria that has to be satisfied in order for you to have a max or min. So what you could simply say is neither. You don't have to write incomplete sentences on the AP exam. Let's leave that for your AP Lang, AP Lit exams. You can just list out the phrases that are most important. So we'll say that there is neither a local max or min. Probably don't even have to write that out. You can certainly abbreviate, you guys. We as readers see all sorts of abbreviations, just use enough letters that definitely convey the meaning of what you're trying to say. So neither a local max nor a local min at x equal 2. Now I might want to make sure I state why, and the reason is because, I love B/C for because, it's because, well, g prime of 2 is not equal to 0 nor undefined. And if a reader was like, oh, well, how do you know that's true? Oh, I can see this work that this student did over here, and they got the answer of 3. Okay, take a look at part D now. Find any x values where the graph of f has a point of inflection. Explain your reasoning. Now, I don't know if you can catch this, but I'm really messing with you right now. I'm jumping back and forth purposely between the graph of f prime, the function g, to really try to keep you guys on your toes here. So point of inflection, f. So again, don't let calculus stand in the way of the calculus that you know. Let's hope that points of inflection you realize are connected to the second derivative. Okay, so I probably need to look at f double prime. Okay, well, that's fine. I'll look at f double prime all day long if you can show me an f prime, or an f double prime, I should say. And we don't see a graph or an equation of f double prime, but what we do see is this graph of f. And one of the strategies that sometimes I like to use with this is kind of setting up a table where I have function on one side and feature on the other side. It's called my function feature table. Now, what do I mean by this? Well, I have really 3 functions that seem to be kind of at the forefront of this problem when you deal with f. I have f, f prime, and f double prime. And I want to know when f double prime, or I'm sorry, I want to know when f has a point of inflection. So I guess that would be the feature, a POI of f. So I want to think about, well, what does that mean about f prime or f double prime? And most students probably connect that feature to the f double prime first. Maybe you're thinking that that means that f double prime changes signs. And if you're thinking that, you're thinking correctly. Awesome. But what we need to do is find this middle functions feature, because the middle function, f prime, is really what we have to work with. So we think about, well, what happens if f double prime changes signs? What happens if any first derivative of a function changed signs? Doesn't that mean that we potentially go from increasing to decreasing, or maybe we go from decreasing to increasing? We change that feature, and that's exactly what's happening with f prime. We change, I'll call it increasing, decreasing behavior, because that kind of takes care of both directions. All right, because if you think about this, f could be some other generic function that I'm going to call it w, right, just for the sake of argument. Well, f double prime would be w prime, right? So you can see how I'm applying that idea of the first derivative to w to test whether it's increasing or decreasing. All
Um,
right, so yes.
yeah, quick question, and I may have missed
Mhm.
it because I was monitoring the chats. Someone asked, G prime does not have an F prime in your part B, but it does in part C.
Oh, goodness. Um, so G, I'm sorry, Aaron, could you say that again now?
They asked if there was a mistake. They said that G prime does not have an F prime in part B, but it does in part C.
Oh my goodness. Oh my goodness. That is like the question of the day, and that's a great, great, great question. I think that I have inadvertently put a prime here that should not belong. Now, I think we're going to be good with our final answer, but I want to make sure that we adjust this numerical value because you are 100% correct. If this is G first prime, there should not be a prime mark here. So let's kind of retrace this. I want to take away the prime mark there, right? Now I'm finding f of 4. Good news. Didn't we already do that a moment ago? The f of 4 is going to be 8 minus pi, I believe. Is that right? And then I still have this plus 1. Whoops. This should be a parenthesis here, you guys. And then once I do all that calculation, I'm pretty certain that's not going to give me 0 nor undefined, right? I guess we could say this. We could sort of cop out and say something like that. But I'm so glad that student pointed that out because it was wrong. It was incorrect. I would have not have been awarded full credit. I could have still got the credit for the actual answer here, but my work would have been problematic. I would love to say that I did that on purpose to kind of illustrate that point, but no, I missed that. And I want to thank you for correcting me. And please don't feel free to correct me as much as you need. I have made mistakes on live national videos in front of 20,000 students, so I'm okay with it. I'm over. All right, so if we get back to part D, find any values of x where f has a point of inflection. Explain the reasoning. Well, remember, we wanted to say that f prime is something that we want to look for changing signs of its derivative, or in this case, changing its increasing, decreasing behavior. So if we look at our f prime and we think, okay, where does this change increasing, decreasing behavior? And we find out that that's going to happen, well, not so much here. That's just a zero, it's a slope that's 0. It's not really increasing nor decreasing. Here we decrease and then we start to increase. So I like what's happening at -1. What about at 0, you guys? Do you think that f prime is changing, increasing to decreasing behavior? Yeah, I certainly think so. What about at 2? All right, looks like we're decreasing. We kind of come to the sharp turn and no, we're still going to decrease. And then we get to 4, we're going to decrease and then increase. So 4 is going to be, I think, our last place. Okay. Now, some students think, well, wait a minute, how could you include some of these values because they have sharp turns? I know sharp turns have significance in calculus, but that just simply means that a derivative isn't defined there. That's not what we're really trying to do here. We're trying to behave or analyze the behavior of what's going on around that derivative, okay? So there's a lot of different ways that you can explain your reasoning here, but one of which is to say that f has a POI, or f has POIs. POIs is a perfectly acceptable abbreviation. We see it all the time. At x equal -1, 0, and 4. And your reasoning, well, let's see. The reasoning would be because, I guess we could say f double prime changes signs. Could we say f prime changes increasing behavior? Typically, both will be accepted. The strongest argument is to say both of them, but sometimes the best argument is to use what has been provided in the problem. That's typically going to give you the path of least resistance to that maximum score. Now, what do I mean by that? Well, you're given f prime in this graph. So it's obvious that they want you to use information about f prime. Perhaps they're afraid that a student just might memorize, oh, f double prime changes signs, f point of inflection, kind of robotically. So let's use the information that was given, and we'll say it's because f prime changes, and we could probably lump it into one group. It changes increasing and decreasing behavior at those values. And my pen is slow all of a sudden. I think that each video that I do each day, the pen gets slower. I think it just gets tired. I think this is my fourth one that I've done today. It's only, not even 2 o'clock here on the East Coast. All right, that's a good explanation. A better one might be to break it down even more specifically and say, okay, at -1, the change is decrease to increase. At 0, it's increase to decrease. And you could lump 4 and -1 together. It's probably a better explanation, but if you're able to kind of convey that idea that the increasing and decreasing changes, it switches from one to another, you're going to be okay in that situation. All right, take a look at part E. Part E is going to be a really good. I want to make sure that we hit this up. It seems like I'm always tasked with reading these absolute extrema questions on the AP exam, and I've always seen lots of students who get most of the points but just aren't able to get all of the points. So it says find the maximum value of f on the closed interval -1 to 4, and we want to justify the answer. So again, we think about maximum value. Now this one didn't say local max or global max, didn't say relative or absolute, but that is on you to decide, because if they give you a closed interval, all systems go for that thing called the extreme value theorem, which basically says that this function, if it's continuous, and we know that it is because it's mentioned to be differentiable, it's going to have both a relative or an absolute max and an absolute min. In this case, we want to find just the max value. So we know that that focuses or starts with the process of taking the derivative of f and setting that equal to 0. Well, as we look at this graph, we find, okay, well, where does this graph equal 0 on the interval -1? So I'm only worried about from here to here. So where does that graph equal 0? And I find that it does equal 0 at that left endpoint, but I'm not so worried about him because we're going to use him anyway. You'll see in a moment. But this 2 is very, very interesting to me. That 2 kind of gets me thinking here that maybe he is the place where the f prime, or where the f, I should say, has x. Now, let's talk about the obvious thing that you don't want to do. The obvious thing is to not say, oh, there's my max, right? It's the highest point. I will give you the fact that is probably your max for the graph of f prime, but we are asked, what is the max of f? You see how it's a little bit more complicated question when it comes to that. So x equal 2 is going to be certainly a possibility, but the extreme value theorem, if you recall, states that you have to test the endpoints as well. So what does that all mean? Well, I think the best way is just to round those all up, and we call them sometimes the candidates. Perhaps you heard your teacher say, oh, you're going to use the candidates test. I love using that. We have this idea called the first derivative test, the second derivative test, candidates test. They're all amazing tests because they can help us figure out extrema if we use them correctly. So the candidate test says that we're going to use our endpoints, -1, we'll use our critical values that we got, and we'll use, again, the other endpoint. Okay. Now, I'd like to say something. We had an issue, I think, a couple of days ago on our program, where there were so many candidates here that students weren't really eager to put them into a chart. So, what if, just for instance, guys, what if this graph did something crazy like this? What if it dropped below 1 like that, and then came back up and then did some other stuff? Well, obviously 1 would then become a candidate, okay? It would become a very viable candidate. But do you guys realize that 2 could be tossed to the curb in terms of trying to find a maximum? And the reason is because at 2, don't you see that f prime changes from a negative to a positive? Is there any way that could be the behavior of f prime to produce a maximum value of any kind? Because if you start to think about that, isn't that a place where there's a relative minimum? Can a relative minimum be an absolute maximum? It's not likely. Now, the problem with that is that if you just exclude any relative minimum from the table, you have to state why. And so often kids don't do that. So often very bright kids may not do that. So you either have to just bite the bullet, include it in the table, and it's not going to turn out to be the max value, I'll guarantee it. Or you could just simply say, I excluded x equal 2 because f prime changes from a negative to a positive. Okay, sometimes that can be quicker. All right, now from here, we're going to do our lovely table of values. That's kind of the approach that I use with my students. And I simply say, okay, we're going to plug an x in there, and we're going to figure out what f of x is. Who are our x's? Well, they happen to be -1, 2, and 4. You can put them in any order that you want. It doesn't have to be in ascending order like that. And then we're kind of back to what we were doing earlier in, say, part A. We're thinking about, okay, to figure out what f of -1 is, we might want to think about integrating from 0 to -1. Ooh, did I do that? Did I just do that? I don't want to do that, right? Would it work? Of course it would work. It would work fine, but it's a little bit clunky and you're not really used to having those boundaries being written in such a crazy way. So how about we integrate from -1 to 0 and just realize that that's going to produce f of 0 minus f of -1. And then what you can see is that this f of -1 is what you're solving for. So hopefully you see that it's very much like part A. So if I were to work this out and find the area between -1 and 0, I'm going to clean up this graph a little bit. It's starting to get a little messy there. Let's see, go away. There we go. So if I have this triangle here, a 1 by 2 triangle, that area would be 1/2 times 1 times 2. It's positive because we're located above the x-axis. So I'll say 1/2 times 1 times 2, and that would equal 6. And then I would subtract f of -1. Okay, and then if I add f of -1 over to the left, I can then subtract essentially 1 over to the right side, and I want to say that my answer is going to be 5. Okay, now again, there are other ways that you could set this up. Some teachers might have their students set it up like uh, um, begin with your initial condition, right? Begin with the f of 0, and then you would tack on the integral that you're going to accumulate. That's perfectly acceptable. I have just found that my students tend to like this basic form of the fundamental theorem of calculus just a little bit better. All right, for the sake of time, I'm going to go ahead and just set up to, which would look like this, the integration from 0 to 2 of f prime of x dx. And know that that's going to be equivalent to f of 2 minus f of 0. Okay, so what that means is when I find the integral from 0 to 2, remember we kind of worked on that already. That was that part of this little sliver that was a matter of taking a square minus a quarter circle. Once you compute that and you add the f of 0, which is 6, back over to the other side, we should come to the realization that f of 2 is 10 minus pi. Okay, that's important. I had to write that because I believe that that's going to be our max. Now, don't feel like you have to reinvent the wheel on the AP exam. I know that there have been many questions on previous exams where if you've done a previous part of a question, you can import that answer into a latter part without having to recreate your work. And if I recall, f of 4 was exactly what we did to kick things off, right? That was our first problem. And remember, 8 minus pi, after I corrected my mistake, my first mistake of the day. And so we can just drop that right in. It's perfectly reasonable to do that. Now, some of you might be thinking, what if I made a mistake in part A? You guys, it's okay. If you make that mistake, that's probably a point that you won't earn, but please understand that that doesn't mean that any time that that value is going to be needed later, that you're automatically out of luck and you can't earn any more points. Quite often, we have to read with students with a mistake, and if they still capture the essence of the problem, if they don't make the problem too much easier, and if they're really illustrating the calculus concept that we're trying to assess, you can still earn full credit even if you use a wrong answer. Now, when you take careful inventory of all of these values, 5, 10 minus pi, and 8 minus pi, you have to think about which one is the largest. And I have seen so many students on the AP exams that I have graded stop right here, and I guess they're just thinking, oh, the teacher's smart enough, the reader's smart enough, they can tell what number's the biggest, but you have to draw our attention to it. One way, you could circle it and write abs max right next to it, that's okay. Or probably the best approach is you could say that the absolute max or the global maximum. If you just say the word maximum, I think we're going to be okay with that because that's the way that we presented it to you. But you definitely want to say the y value, the f of x value. Okay, we're not interested in where it occurs. We can see where it occurs by looking at your table. If you write which occurs when x is 2, that's perfectly fine, but it's not really necessary. All right, and then we'll look here at part F, which I believe is our last part of this question, if I'm not mistaken. And I kind of, this really is one of the more difficult problems here, and I want to I want to try to get it started at least, and I'd invite you to, you can always, I believe that you have, students have access to the solution guide, maybe, I know that your teachers do, but there's a lot of really interesting communication language in this problem that can be very, very tricky. On the surface, it seems pretty laid back. Does the graph of G have a point of inflection at 2? Okay, well, point of inflection means that we're going to talk about the second derivative of G. So we have to think about G double prime. Now, wait a minute, I think we've been there before. I think in part B, we computed that to be -4 f prime of 2x. Okay, now I want the f prime there, right? Because this is the second derivative of G. So we have to think about, okay, what does it mean to have a point of inflection? Well, that means that the second derivative evaluated at 2 has to be either equal to 0 or undefined. So G double prime of 2, what are you equal to? What are you equal to? Well, I'm going to tell you. I am -4 f prime of 4, right? -4 f prime of 4. Okay, so what is my value of f prime of 4 going to be? Okay, well, I look back at this and I see that my value at 4 is going to be -2. So if I'm doing this right, -4 times -2 is 8, correct? Okay, so now I have to think about the next phase of the problem. I have a G double prime that's equal to, well, it's equal to something that's definitely not equal to 0. That's never a good thing when you're trying to find a point of inflection. So we're going to say that we don't have a point of inflection for this problem. So G of x has no POI, whoops, at x equal 2. And for a similar reason, it's because G double prime of 2 is not equal to 0 nor undefined. And it's funny that you've seen a couple of problems that ask you for the existence of a certain point, and so often the answer is yes to those questions. And I try to turn the tables a little bit to make that not be the case in this particular instance. Okay. Now I want to talk a little bit about problem 2. I don't think we're going to be able to do all of the parts for this, but I want to maybe highlight some of the key features of this because it is a problem that's what we call a tabular stem. And we feel that you have the potential to see tables on this year's AP exam because again, it's very difficult for you to use a CAS calculator. You probably can't use the PhotoMath app to answer questions that have data that are presented in tables. So we have f and g are twice differentiable, all values of x, selected values of f and g, and their derivatives f prime and g prime are given in this table. We're going to let h of x be f of g of 2x, and our job is to find h prime of 1. All right, so how do you take the derivative of h of x if it's this horrible looking monstrosity that you see in front of you, right? This f of g of 2x. So what you're going to do with this is you're going to take the derivative of h and not let calculus stand in the way of the calculus that you know. What we have is a super composite function. Sometimes I call this the peanut M&M, or I don't know, have you ever had like one of those Charms Blow Pop suckers, right? They have 3 layers to them. The outside is a wrapper, the inside is hard candy, and then inside of that is that bubblegum center. That's really what we have. Wrapper, candy, bubblegum center, right? So we're going to take the derivative of the outside, that would be f prime. We're going to keep the inside intact, which is g of 2x, right? After all, whenever you remove that paper, Taking a derivative is removing. You don't change the candy. It's all the same. The gum is the same. And now you start working away at the candy center, and you start taking, chomps of that or whatever, and you take the derivative of G, and you get G prime of 2x, and then you get to the bubblegum center, and we all know that's the favorite part, right? And we take the derivative of the 2x, and we would get 2. And so that would be a way that we could express this particular derivative. That probably is going to earn some points, but we haven't done exactly the problem has requested, and that is to find the value specifically at 1. So we have to extract values from the table and make sure that we put them into our answer, because we won't earn full credit if we leave things in terms of f of x, g of x, etc. So we just kind of work through this carefully. G of 2 times 1 is g of 2, of course. And we have g prime of 2 times 1 times 2. And g of 2 is what we're looking at. First of all, from the table, g of 2 looks like it's going to be a 4. G prime of 2 from the table looks like it's going to be a 5. And then, oh my gosh, we still have to read this f prime value, f prime of 4. Well, it looks like f prime of 4 is going to be, I believe, a 1. And it's probably not too difficult to multiply 1, 5, and 2 together to get 10. Okay. Now, what I think is a very strong possibility on your exam is potentially to have a problem that might be a hybrid. Maybe you'll have a graph and a table that you have to work with. They've been asked before on the AP exam. Be honest, you guys, I don't know any more than Aaron does, than Michael does, than your teachers do. We're all in the same boat. And all we can do is just prepare as best we can, do as many practice problems, use the resources that are out there for us, and then just really hope for the best and show up on exam day well rested and do as good of a job as we can. All right, we haven't done a whole lot with integration in terms of its actual procedural approach, its analytic approach, and I'd like to take a look at that here with part B, because I'm fairly certain that you're going to see some kind of analytic, pseudo-analytic tabular method, pseudo-analytic graphical STEM method approach to our integration problem this year. So what do I mean by that? Well, because we're trying to integrate f prime of 2x minus 3, again, a calculator is probably really going to struggle with that, because the calculator is going to be thinking, well, what is your function f going to be? Well, we can't just simply integrate f prime of 2x minus 3 and just assume that we get f of 2x minus 3, because there's a lot more going on to this, right? And perhaps you recall that good friend of yours, U substitution. U substitution is probably maybe the most complex integration technique that you guys have learned in AB calculus. Certainly it kind of goes along with some of those other techniques that ran alongside it, but of course, that's going to change when you get to BC or if you take Calc 2, because the integration techniques start to get a lot more complicated, but you'll be ready if you guys take Calc 2. So you're going to take this derivative and you're going to get 2 and move our dx over to the other side, right? Instead of putting it underneath the du. And basically what this says to us is, first of all, this problem is horribly written. Now it's better. It should have a dx in there. I have to talk to my partner about that, make sure we switch that on our other documents, but there should be a dx there, otherwise it doesn't make sense. Yeah, these problems are hot off the press, you guys. They haven't been written for very long. And then we have to realize that if we wanted this dx to be removed, then we would solve for it, and we basically get du over 2. And that's the whole point of you having the ability to bring a 1/2 to the front of the integral. I call that offsetting with a 1/2 when I speak to my students, offset with 1/2. And then we have this integration f prime of u du, right? But one thing that's going to be very important to you, especially if you stay in the world of you, right? On our show this morning, we had a guest speaker, former chief reader Steve Kokoska, talked at great length about this, is that we want to make sure that we change these boundaries, right? We want to make sure that this 4 ends up plugging in for this x. We get 2 times 4, which is 8, minus 3, which is 5. And then we can do the same thing with this 2. 2 times 2 minus 3 is going to be what? 1. And then at this point, we could proceed with this process and say, oh, the integration of f prime is just indeed f, right? F of the variable u in this case, with our boundaries now, our new boundaries 5 and 1. And now we should be able to finish it off by plopping in 5, plopping in our 1, and then I think we can read from the table. Now remember, you're not finished until you read from the table. And f of 5 is going to be 1, f of 1 is -1, and boy, I'll be happy if this answer is 1, because that's what it says on my key here. Yes, it is 1, right? Half of 2, okay? One thing that we want to warn you about is there's this thing called linkage. It's very likely that a student doesn't know a lot about linkage. I'm going to tell you, it's very likely that some teachers don't know much about linkage errors. I certainly didn't know what linkage errors were before I became a reader. And what that is that let's say a student puts an equal sign between this step and the step that I have here highlighted, but they still used boundaries like this. They used the original boundaries. That could be an issue because these two things certainly aren't equivalent to each other, right? If we were to integrate f prime and get f and then plug in 4 minus 2, I'd seriously doubt that we're going to get 1. So you want to be very careful if you use a lot of equal signs. In fact, you guys, you could survive without having to use many equal signs. I think one of the best ways to do that is to organize your work vertically. Don't really even worry about putting equal signs in front. And that way, if let's say you write something that maybe not be equivalent to the top, a lot of times we'll look at that and think, what's the student thinking? Are they just kind of restarting? Are they kind of beginning the problem again by using these new boundaries? And thus you won't suffer a linkage error. So it's advice that I've definitely given to my students from the experience that I've had at the reading. I just want to highlight a couple of other parts of this. I'm not going to do them. I would certainly encourage them. I don't know. Am I allowed to give homework? Can I give homework tonight? Is that allowed?
As long as you
So
want to
maybe you
accept it
could do
all.
these problems. All right. So you could work through some of these problems. There's not very many more, but Part C is a wonderful derivative rule that you can practice. I'm not going to give it away. Hopefully you can kind of see which one you're going to use, but it's one that certainly won't be benefited by using a CAS calculator. And then got a limit problem. I'm going to let you kind of think about, I wonder what process that we would use for this limit. Well, one thing I want to say, if this is a L'Hopital's rule, you've heard maybe many times from your teachers, because the teachers in your program are very good about this. They know these rules. You want to make sure that if you state that a limit of a rational expression has a 0 on top and a 0 on bottom, break those two things apart separately. So in other words, I'm not going to write it all out, but write the limit as x approaches 5 of the top, write the limit as x approaches 5, and then rewrite the bottom, and then show that those individually are both 0, or show that they both maybe approach infinity. And that's your green light to go ahead and talk about using L'Hopital's rule from that point. If it were me on this particular problem, I would make mention of the fact that f and g are continuous functions. Teachers, you know what I'm talking about. We were burned by that a couple of years ago, weren't we? Whenever we try to just directly substitute a value in for a function, we have to be very careful because we can't do that to find a limit unless we know that function is continuous. And the reason that we know that f and g are continuous is because the problem states that they're both twice differentiable. So once that groundwork is laid out, you can proceed with your L'Hopital's rule, which involves taking the derivative of the top and the bottom. So there, I did maybe half the problem for you, so you guys should be fine to finish up. Part E is a wonderful question that talks about particle motion. Now, the particle motion that's going to be on your exam this year is very limited. There won't be any mention of particle motion that involves an integral. That was going to be in Unit 8. So we can push that aside and you can just focus on the things particle motion related that are derivative, like maybe are particles moving to the left, moving to the right, speeding up, slowing down, which is what part F is all about, right? And then going back to part E, we couldn't use the idea of whether these particles are moving away or towards each other if we think about both what their position and what their velocities are. Okay, and like I said, the key is posted, and you can gain access to that by whichever means that you're allowed, and kind of look at these problems and kind of think about, um, what how close you would be to getting the full answer to how many points that you think that you might receive. And you're going to notice purposely, yeah, we didn't put point values for these problems. In fact, as the community in our YouTube live videos, we're actually told not to do that. And it's because we would just be guessing. I don't know how many points the problems are going to be worth. Traditionally, a free response is worth 9 and 9. I'm probably thinking that may not be the case this year. Maybe they're going to be worth more points. Maybe it's going to be more granular. In other words, maybe you'll get many more small points for doing smaller things. We have no way of knowing. But why worry about that, right? Let's let the readers take care of that. All you need to worry about is spending the next week practicing, practicing, practicing the calculus, get better each day. It's not like there's a whole lot of other things to do anyway, right? And then find yourself in a very confident position come next Tuesday. I wanted to share something here really quick with you. You're welcome to take a screenshot of this. If you have your phone nearby, you can take a photograph. But these are, like, I think, the College Board most important links. These are the things that we're sharing out each morning. And so I would really encourage you to visit each and every one of these sites. Some of them contain some interesting documents that will be helpful. Some of them are actually links to videos, like the bottom two, and they're very well made by the College Board, and I think they explain a lot of things clearly. And if I had to outline what I feel to be the most important one of these, oh my goodness, number 2. Write this down and memorize that if you haven't already. And I'm sure that there's a great deal of you that probably have. I know we're kind of at capacity in this room. There's so many of you that are joining us today, and I'm so thankful that you're here. But I bet many of you have probably practiced this once or twice, the upload procedure. It's easy to do. You can do it a number of times. Have fun with it. Do it multiple times and just time yourself and see how fast you can get at it, how efficient that you can get at it each time. I really encourage that. cb.org/AP demo might be the most important place to go to, because let's be honest, guys, you could have a killer test that is a 5. If we don't get it submitted correctly, then that's going to cause some problems, right? And we're not going to be able to show the world that we did what we did here. And I got one other really quick thing here I show. It's just a slides of some things that I've shared on the BC group. And it applies to you guys as well, even though it says BC. But what are some things that you can do, right, before exam day? Find out where you're going to test. Go to that place. Make sure it's free of distractions. Make sure your Wi-Fi signal is good if you're not directly plugged in. Definitely let your friends and family know what's going on that day. You want to make sure that they aren't going to be texting you, calling you, walking by, or whatever, especially if you live in a home with lots of siblings, lots of maybe younger siblings. You know what I'm talking about. Prepare your papers ahead of time. Take some 8.5 by 11 sheets of paper. They can be plain white computer paper. They can be lined notebook paper. It doesn't matter. And have them laid out and put your AP ID, your initials, and the page number already at the top of each page so that they're ready to go. Lay out several ends in case the ink goes bad. You can use pencil. Just make sure that it's really dark pencil and that it can be read if you take a photograph, and then you're all set to go. Now, notice I'm kind of leaning towards those of you who are going to do a handwritten submission and take pictures. Some of you may opt for the other procedure, which is very well explained in the documents that I presented, and you're welcome to do that. Just practice that first, because it might be a little different to type in mathematics. It might be weird to type in limits and integrals, but the College Board has released a document that gives you some guidelines about what characters you can use for those particular symbols. So if you're kind of thinking about it, certainly, give it a shot. That document, like as I said before, is posted in the files that I had just showed you on the previous slide. Okay. If you're wondering about your APID, we're going to talk about that in a second. As a technical setup, what are you going to do? You're going to practice, practice, practice that upload procedure at cb.org/apdemo. That's every bit as important now as just studying and learning calculus. Make sure you develop an efficient routine. If you're going to take photographs with your phone, maybe set up a desktop on your screen so that you can have those photos uploaded, whether you decide to store them there via an email attachment. Maybe you use cloud storage That's all good. You want to make sure that the photos are sent in a JPEG form. Your Apple users, there's a possibility that sometimes your pictures, especially if they're airdropped, might be an HEIC format. Those are not going to be accepted. So just check that when you go through that practice process, okay? Make sure your devices are fully charged. Turn off all your notifications for social media. You don't need that for that period of time. And then your ID number, which is going to be available 48 hours before the exam, that would be Sunday, May 10th, is going to be available for you to use. You're actually going to also get a ticket number that's going to be available before the exam as well. So you have this ID number and then you have a ticket number. And the videos do a really good job of explaining that. And that's what you kind of need to focus on before exam day, what's on those 2 slides, because what you do to prepare, I think, is going to have a very big direct impact on how well that you perform. And my clock here says 2 Eastern. So Aaron, are we good? Did I get everything covered? I feel like we went pretty quickly, but
I know it flies. No, thank you very much. You did an incredible job.
thank you.
We only had a couple questions, but you got to all of them except for someone pointed out that your solution packet needs to be updated with that BC part with the F prime.
Yes, I will do that. And if any of you had, there was a first version of my packet that had another problem, part A, associated with problem 2. There were some issues with that I didn't think were going to be pertinent to this year's exam, so I pulled that. So there's actually 1 fewer question on the document that I did today. But what is in the Dropbox is current. And here, as soon as we get off, I'm going to double check that solution key, so it's going to be accurate for you if you want to use that. So yeah, thanks.
I'm going to share my screen here just to wrap up.
Mhm.
All right, so again, any questions for Tony, Michael, or myself can be directed to us. Tony's email is there, his Twitter handle, give him a follow, as well as all of us. We'll be happy to get back to you with any questions you have. Today's recording will be posted to kyap2020.com, and then the link to the handouts will also be included there, but you can go there now. Both the solution and the questions from today are up. Just you may want to give it a few hours for Tony to make sure everything is in good line. But other than that, next week, Tuesday, May 12th, 2 p.m., that is the AP Calculus exam. So that is what you'll be doing here starting 2 minutes ago. So Michael, Tony, if you have any other closing thoughts, would you like to say anything before we sign off?
Thank you, Tony.
You
That
know,
was excellent.
thank you, Michael. Thanks. You guys do such great things. I've said this so many times. Kids, you are so lucky to be in this organization. It's top notch, and I know your teachers feel the same way. And you have some amazing teachers, and they believe in you. Aaron believes in you. Michael believes in you. I believe in you. You know, seniors especially. I know this is tough. This is really tough on you, but like I said, rewrite this chapter. You have the chance to do that. We know that you can do it. Just a few more days of some extra work. Get this calculus exam behind you. Start maybe looking at your other AP exams. We care about those too. We want you to do well, and we know that you can do it.
Very well said. I don't think I can follow that up. So thank you very much, Tony. Those of you that might be in BC or have friends or other teachers in BC, we have a review session on Thursday for that. So check out our website for that. But nothing else. Best of luck to all of you out there taking the AP exam next week. And we will see you somewhere down the road. Thank you.
Take care, everybody.